Hi guys, this is a video to help you practice moments questions for IGCSE physics. In each one of these questions, I'll show you the question and then you'll have to find the missing force, F, and then you can pause the video and figure it out for yourself, and then I will do the working out. So here's question number 1. You have a 20 Newton force on the left-hand side, 0.6 meters away from the pivot, and you have a 1 meter away, you have another force. In every single one of these examples, the beam is balanced. Okay, so you've got to find F. Okay, so for the solution for this, we need to take we know that the beam is balanced, so we need to take all of the anti-clockwise moments and all of the clockwise moments, and we know that they are equal to each other. So the anti-clockwise moments going this way are 20 times 0.6, and the clockwise moments, which are equal to the anti-clockwise moments, is F times 1.0. So F is just equal to 20 times 0.6, which is 12 newtons. Okay, question number 2. Here's question number 2. You have a force F 0.2 meters away from the pivot. You have a force of 30 meters, 1.8 meters away on the other side of the pivot, and we have to find F. Okay, so we're going to do the same thing as we did in the first question. We're going to balance the clockwise and the anti-clockwise moments. So the anti-clockwise moments going this way are F times 0.2. The clockwise moments here are 30 times 1.8. So then to find F, we need to do 30 times 1.8 divided by 0.2, which gives us an F of 270 newtons. Okay, question number 3. You have more forces here. Okay, for the solution for this one, the same principle applies. So we're going to take all the clockwise moments and add them and equate them to all the anti-clockwise moments. So the anti-clockwise moments, there's 2 of them, and there's 2 clockwise moments. So we've got the anti-clockwise moments here. So remember, the distance is always the distance to the pivot, not the distance from one force to the other force. So the 120 newtons there is actually times 10 meters because it's 10 meters away from the pivot. So we're going to put that in brackets. Plus this one, because this is also an anti-clockwise moment. So plus 60 times 5, that one's 5 meters away from the pivot, equals 100. Again, the 100 newtons is a clockwise moment, but is 10 meters away from the pivot, not 8 meters. So 10 meters away from the pivot, plus F times 2. Okay, and we can solve that for F. So that gives us 1,200 plus 300 equals 1,000 plus 2F. So that gives us 2F equals 500. So F equals 250 newtons. Okay, question number 4. You've got 3 forces. You've got 4 forces here. Okay, you need to know the distances, which I haven't included in the diagram. Poor form. So let's say that F is 3 meters. That distance there to the 80 newtons is 2 meters. That distance there is 2 meters, and that distance there is 2 meters. Okay, now you can give it a go. Okay, for the solution to this one, we need to do exactly the same thing, but this time we've got an arrow pointing up here. So we have to figure out if that's a clockwise or an anti-clockwise moment. So remember that the pivot is the center of the clock. So we've got this one, which is an anti-clockwise moment. This one is actually going the same direction. If that's the center of the clock there, then this one is going the same direction around that center as F. So that is also an anti-clockwise moment, and these two are clockwise moments. Okay, so we've got our anti-clockwise moments, which is 80 times 2 plus F times 3. And that equals 60 times 4, because it's 4 meters away from the pivot. 60 times 4 and plus 90 times 6. Okay, and that is going to give us 80 times 2 is 160 plus 3F equals 60 times 4, which is 240 plus 90 times 6, which is 540. So that gives us 240 plus 540 is 780, minus 160 is 3F. So then F must be equal to 620 divided by 3, which is 206.6666, so we're going to say 207 newtons, round it to 3 significant figures. Question number 5. I'll let you have a go at this one now. Okay, for question number 5, we need to do exactly the same thing, but this time we need to remember that we are talking about the perpendicular distance from the pivot. That's what we're multiplying the force by. So the perpendicular distance, it means it's perpendicular to the direction of the force. So here the force is going vertically downwards. And so what we need to do is pay attention to the perpendicular distance to the pivot, not this distance, which is at a different angle. The perpendicular distance is this one here. So we have F times 1.8, and the same thing applies here to this 1,000 newtons. We want the perpendicular distance, the one that is at right angles to the force. So we've got 1,000 times 0.3. Whoops, 1,000 times 0.3. So that gives us 1.8 F equals 300. 300 divided by 1.8 is 166.666666. So we're going to say 167 newtons to 3 significant figures. Okay, thanks very much. In the description to this video, there are some more exam-style questions with the mark schemes attached to them. So take a look in the description of the video for more questions. Good luck.